An increasing number of scientists are beginning to harbor doubts that our universe is truly real, but rather an immense code of unimaginable scale, akin to an intricate computer program running without pause, with us as unwitting characters within it. Imagine yourself seated there, in your familiar room, listening to the gentle breeze whispering through the window, feeling the steady rhythm of your heartbeat, and then suddenly pondering. All of this might merely be data being processed somewhere distant. That sensation sends a slight shiver down your spine, does it not? It resembles the moment you awaken from a vivid dream and question, which is the true reality? This narrative commences with a prophecy in the 1960s, when the mathematician John von Neumann, one of the great minds who contributed to the foundation of modern computers, remarked that if a civilization was sufficiently advanced, it could simulate the entire universe. And within this simulation, life would emerge, develop, evolve, and those beings would naturally assume their existence to be genuine, just as we perceive our own. At the time, such words seemed like mere science fiction, largely disregarded, for the world was preoccupied with technological races and space explorations. Yet now, in the year 2025, an escalating array of evidence points towards a possibility that stirs the soul. We are inhabiting a highly simulated cosmic program, where everything from the twinkling stars in the night sky to the warm breath escaping your lips is the outcome of sophisticated algorithms. To grasp this more fully, let us rewind a little through the history of this concept, for it is not novel, but has woven itself through millennia of human contemplation. From ancient times, the Chinese philosopher Zhuangzi dreamt of a butterfly and wondered whether he was a man dreaming of a butterfly, or a butterfly dreaming of him, evoking profound skepticism about reality. In ancient India, the notion of Maya portrayed the world as an illusion, a veil concealing a deeper truth. Meanwhile, in Greece, Plato depicted life as prisoners in a cave beholding only shadows on the wall, oblivious to the external world. By the 17th century, René Descartes fretted over a malevolent demon that might deceive all our senses. These ideas drifted like fleeting winds through history, but in 1969, Konrad Zuse, the father of the digital computer, proposed that the universe might be a colossal computational system. And today, with the advancement of artificial intelligence and quantum computers, such thoughts are no longer vague philosophy, but a fervent topic at scientific conferences, where physicists gather round tables, debating vigorously under the glow of neon lights, with the aroma of coffee pervading the air, striving to uncover evidence for an alternate reality. Recent discussions in 2025, including those at forums like the Simons Foundation and R14 preprints, have revisited these historical threads, incorporating modern simulations that model ancient philosophical dilemmas through quantum algorithms, suggesting that the boundary between dream and reality may be computationally blurred, enhancing the depth of these age-old queries. The first peculiarity is the precision of the universe, a fact that leaves one wide-eyed in astonishment upon reflection. Scientists have discovered that all the physical constants in nature, whether the gravitational constant determining how planets orbit one another, the minuscule mass of the proton that maintains atomic stability, the rate of cosmic expansion causing space to inflate like a balloon gradually swelling, or the quantum forces governing the microscopic realm, are tuned with such exactitude as if calibrated by hand, with a finesse that evokes the image of someone meticulously adjusting dials to ensure a perfect fit. Should any one of these parameters deviate by even a millionth part, the universe could not form. Galaxies would not exist with their swirling vortices of glittering stars in the dark void. Life would not arise. There would be no verdant earth with the murmuring waves lapping at shores or birdsong greeting the dawn. Even more strangely, the universe appears calibrated to a degree that is precisely sufficient, neither excessive nor deficient, resembling a machine engineered to sustain life flawlessly. This extreme perfection prompts the scientific community to posit a startling hypothesis. The universe is not randomly suited to life, but perhaps life, including ourselves, is the result of intentional design, or at least a simulation where parameters are set to yield desired outcomes. This ties into the anthropic principle, where scholars like Leonard Susskind explain that among countless possible universes, we observe this one, because it permits our existence to observe it, akin to hearing your favorite melody only because it plays in the room where you sit. In 2025, fresh research from institutions, such as the University of Cambridge and published in Religious Studies Journal has refined this view, incorporating data from the Dark Energy Spectroscopic Instrument, which maps cosmic structures to test fine-tuning, revealing that slight variations in dark matter density could preclude carbon-based life, thus deepening the anthropic argument with empirical backing from ongoing surveys of billions of galaxies. And to elucidate further, consider the emotion this evokes. You are strolling beneath a starlit sky, cool wind brushing your skin, and abruptly realize that all this harmony might not be chance, but part of a grand program. It inspires awe, making you feel diminutive yet connected to the vast cosmos, as if each breath you take is a seamless line of code executing flawlessly. The second peculiarity is the mathematical structure of the universe, an aspect that elicits a sigh of admiration for its elegance. The mathematician Max Tegmark asserts that the universe does not resemble chaotic reality, but mathematics itself, a flawless logical system. We employ mathematics to describe the universe not merely because it fits well, but because the universe is akin to a logical program constructed from mathematics, with equations as beautiful as wordless symphonies. Do you notice? An electron never abruptly alters its charge. The speed of light remains invariant at 300,000 kilometers per second, like an immutable rule. Nature is not random. It adheres strictly to logic, laws, and algorithms, much like a video game where characters cannot violate rules without causing a system crash. Just as you would not wish your game character to suddenly pass through walls, morph unexpectedly, or soar without reason, for that would shatter consistency. If the universe is a program, then what we call physical laws are not natural but rules, boundaries, frameworks, the fundamental source code, keeping everything running smoothly like the faint hum of a computer in a quiet study. Tegmark has elaborated this into the mathematical universe hypothesis, positing that every existent mathematical structure is a real universe, and ours is merely one among them, where mathematics does not describe reality, but is reality. By 2025, this idea remains vigorously debated, with critics deeming it overly abstract, yet Tegmark counters that it explains the perfect alignment of mathematics with physics, like a key fitting a lock, because they are designed for each other. Recent discussions, including those on platforms like Astral Codex 10 and Philosophy Stack Exchange, have linked this hypothesis to emerging quantum computing models, where simulations of multiverse demonstrate how mathematical consistency could underpin simulated realities, adding layers of computational evidence to Tegmark's framework. Imagine yourself in a library, turning the pages of aged mathematical tomes, the scent of paper lingering, and suddenly sensing that those numerals are not mere symbols, but the bedrock of all around you, stirring your heart with that wonder. The third peculiarity is the behavior of the quantum world, where everything turns bizarre beyond comprehension, leaving you feeling as if lost in a strange dream. Scientists have found that in the realm of subatomic particles, matters become uncannily odd. An electron can occupy multiple positions simultaneously, like a ghost haunting various locales, can both exist and not exist under the principle of superposition, can traverse space to connect instantly with another particle through quantum entanglement, where two particles separated by light years still influence each other, as if distance were non-existent. And what chills one most is that they determine their state only upon observation, like a secret revealed solely when someone gazes upon it. What does this imply? It means that before you look, the outcome does not exist, and only at the moment of observation does reality render itself, akin to an open-world game where the map and textures load only as you approach, while unseen areas remain non-existent, conserving computational resources. It is merely a data structure, a variable awaiting display, and upon observation, you hear an invisible click as the system updates. This phenomenon, termed the observer effect, has been confirmed through innumerable experiments, such as Young's double-slit experiment, where light behaves as wave or particle depending on measurement. By 2025, researchers at facilities like CERN persist in probing entanglement, with new experiments showing it can link not just particles, but larger systems, hinting that reality might be drawn on demand, evoking a mix of excitement and unease, as if standing before a mysterious curtain about to be drawn. Recent studies, including those from New Scientist proposing particle-antiparticle annihilation tests to detect simulation artifacts, have bolstered this view, suggesting quantum anomalies could be signatures of underlying code, thus updating the discourse with potential empirical probes. Evidence the fourth is that the universe possesses a resolution like pixels, a discovery that makes one rub one's eyes in disbelief. In 2012, scientists at America's Femilab National Laboratory conducted an experiment and discerned that space is not continuous, but pixelated, in discrete units, with the smallest being the Planck length, approximately 10 to the power of minus 35 meters, billions of times smaller than an atom. Do you suppose space is infinitely divisible? Not so. It has a minimal unit called the Planck length, below which nothing exists, like a superfine pixel on an enormous screen. Even time is not continuous, but leaps frame by frame, at such high frequency that you perceive no discontinuity, like a film running at hundreds of millions of frames per second. This signifies that the reality we see might be refreshed hundreds of millions of times per second, and the world appears to operate at a fixed frame rate, akin to frames in a game. Only the universe's rate is so elevated that it seems seamless, yet it leaves you feeling as though dwelling in a fluid film, with wind and light flowing ceaselessly. The holometer experiment at Femilab, led by Craig Hogan, sought to detect holographic noise quantum jitter at the Planck scale, using the world's most sensitive laser detectors in dimly lit tunnels with a soft mechanical hum. Though initial results in 2015 found no such noise, subsequent investigations through 2025 continue, with novel proposals to examine space's discreteness via high-energy cosmic rays, stirring the scientific community with anticipation of breakthrough evidence, as documented in recent Instagram analyses and Femilab updates linking this to broader holographic theories. Evidence the fifth is that black holes resemble databases, an idea that sends a chill along the spine when contemplating those abyssal voids. The black hole sovereign Stephen Hawking posited that information swallowed by black holes does not vanish, but is stored encoded at the event horizon's edge, where space bends to extremity. What does this mean? It means the universe wastes no information. It records all events like a vast database, even with error correction mechanisms, akin to computer data safeguarding against corruption, ensuring preservation despite a black hole's ingestion. The black hole information paradox Hawking raised in 1974, where information seemed lost, violating quantum laws, has been addressed by scientists like Leonard Susskind and Juan Maldacena through the holographic principle, encoding information on a black hole's two-dimensional surface. By 2025, advancements such as islands accessible information regions from outside, and hairy black holes with additional properties have neared resolution, with Nature journal articles debating how Hawking radiation extracts information, fostering hope that this enigma is nearing unveiling, like whispers from the depths. Conferences like the one at Stony Brook in 2025 on fuzzball resolutions further enrich this, proposing black holes as tangled string structures that preserve information without paradox, adding quantum gravity insights to the simulation narrative. Evidence the sixth is that the universe executes commands, a process evoking the sense of witnessing a monumental update. The universe's expansion rate does not decelerate, but accelerates, propelled by dark energy, an invisible force comprising 70% of the cosmos. This mirrors a program undergoing back-end upgrades, with dark energy akin to an unseen computational process driving relentless expansion, generating new space at dizzying pace. Even more outlandish is the large-scale structure manifesting distribution patterns like network nodes, resembling an incomprehensible colossal computer circuit diagram, with galaxies linked like neurons in a brain, prompting visions of the universe as a gigantic network computing itself. Recent 2025 findings from the Dark Energy Spectroscopic Instrument and Fugaku supercomputer simulations suggest dark energy may be dynamic, not constant, potentially causing expansion to slow rather than accelerate indefinitely. As per Yonsei University and University of Chicago studies, challenging traditional models and implying adaptive algorithms in a simulated framework, where cosmic evolution adjusts like evolving code. And the philosopher of technology at Harvard University, Nick Bostrom, ultimately delivered a globally shocking conclusion in his 2003 paper. He argued that we might inhabit a simulated world rather than the real one, based on a trilemma. Either humanity will extinguish itself before attaining simulation technology, or advanced civilizations lack interest in running ancestor simulations, or we are almost certainly in a simulation, because the quantity of simulations would vastly outnumber base realities. For if a civilization can simulate universes, it would not simulate just one, but innumerable, with planetary-scale computational resources, whereas base universes are singular, while simulated ones could be infinite. Thus, the probability of residing in base reality approaches zero, a calculation that halts you, draws a deep breath, and prompts introspection about your life. By 2025, Bostrom's argument endures in debates, with some scientists like Zhuangzi from MIT estimating the simulation probability has risen to at least 67% amid AI progress, while mathematical proofs invoking Gödel's incompleteness theorem contend the universe cannot be a complete simulation, as not everything is computable, yet these contentions only heighten the allure. Recent warnings from Bostrom himself, as reported in Reddit and Futurism, highlight RA's role in escalating this likelihood, intertwining simulation theory with superintelligence risks. You might wonder, then, who orchestrates us? The answer could fall into three categories, each stirring distinct emotions. The first is our descendants, future humans with incomprehensible technology, running this simulation to study history, or civilization's evolution, much like we view documentaries of the past with curiosity. The second is a civilization in higher dimensions, where we are mere data to them, our universe perhaps a scientific project, or entertainment, making you feel minuscule like an ant in a vast garden. The third, and most spine-tingling, is no orchestrator at all. Everything is an autonomous system running, and you are but an echo of consciousness arising from code, echoing eternally in the void, with the resonance of algorithms. At this juncture, a question may arise in your mind: if all is simulation, can we escape? The answer is affirmative, for scientists have noted that probing the universe's essence, particularly quantum mechanics, yields inexplicable noise and odd results, as if the program resists revealing its understructure, with experiments like Preston Green's in 2019 cautioning that seeking proof might trigger shutdown. Even more wildly, research groups have inferred the universe's base structure via mathematical models and uncovered patterns akin only to computer code, such as Hamming codes for error correction in data transmission. Upon publication, one scientist remarked, "If the world is scripted, this is its first glitch." a revelation eliciting applause mingled with anxious murmurs in laboratories. Critiques persist, like Sabine Hossenfelder deeming it pseudoscience for lacking measurable evidence, or Sean Carroll arguing it contradicts our consistency. But such views only invigorate the discourse, inspiring younger generations to explore further. Ultimately, I wish to pose a question that resonates within you. Do you feel you possess free will? Do you believe you viewed this because you chose to? Or is it merely a branch you must execute in the program, with the mouse click like a command fulfilled? Perhaps, as you scroll away, the universe branches, in some parallel realm you lingered, and in this one, you have just begun to doubt whether the world you see is real or mere illusion, a thought that brings a smile of curiosity. If one day you truly discover that exit, remember this. It is not you departing the world, but the world finally acknowledging your existence, a moment brimming with inspiration. Are you prepared to continue living in this potentially operating universe? For now, you cannot pretend you have never doubted, and that doubt is the key unlocking new horizons, with the cosmic wind whispering invitations to explore.